Hey class, here's the answer key video for Chapter 6, Lesson 7. The learning target is, I can solve inequalities using multiplication and division. Real world link. An astronaut is in a spacesuit, weighs about 300 pounds on Earth, but only 50 pounds on the moon. Weight on Earth, 300 pounds, is greater than weight on the moon, 50 pounds. If the astronaut and spacesuit each weighed half as much, would the inequality still be true? Divided each side by 2, 300 divided by 2 is 150, and 50 divided by 2 is 25. So is the inequality still true? 150 is greater than 25, so yes, it's still true. Is the weight of one astronaut greater on Pluto or Earth? Would the weight of 5 astronauts be greater on Pluto or on Earth? Explain by using an inequality. So looking at the table, I see Earth is 300 pounds and Pluto is 67. So is the weight of the astronaut greater on Pluto or on Earth? So it's Earth. And would the weight of 5 astronauts be greater on Pluto or on Earth? So you could find that using 300 is greater than 67, and then if you multiply by 5 on both sides, it's still true. Then number 3 says, is the weight of one astronaut greater on Jupiter or on Earth? Would the weight of 5 astronauts be greater on Jupiter or on Earth? Explain using an inequality. So an astronaut that weighs 300 on Earth weighs 796 pounds on Jupiter. So 300 is less than 796. If I multiplied both sides by 5 astronauts, it's still true. So when I multiply both sides of an inequality or divide both sides of an inequality, the inequality is still true. Multiplication and division properties of inequality, positive number. The multiplication property of inequality and the division property of inequality state that an inequality remains true when you multiply or divide each side of an inequality by a positive number. So the symbols for all numbers a, b, and c, where c is greater than 0, if a is greater than b, then ac is greater than bc, and a over c is greater than b over c. If a is less than b, then ac is less than bc, and a over c is less than bc. These properties are also true if a is greater than or equal to b and a is less than or equal to b. You can solve inequalities by using the multiplication property of inequality and the division property of inequality. Stop and reflect. What does the inequality c is greater than 0 mean? It means that c is any number greater than 0. So when I multiply or divide by a positive number, the inequality remains true. Example 1 says solve 8x is less than or equal to 40. So we have to solve for x, and with this type of equation before, to get x by itself, we have to divide both sides by 8. And this becomes 8 divided by 8, which is just 1, so 1 times x is just x, is less than or equal to 40 divided by 8, which is 5. So it's x is less than or equal to 5. So now if I move this out of the way, I can see if I'm right. And it looks like the book got the same answer. The solution is x is less than or equal to 5, and you can check the solution by substituting 5 or a number less than 5 into the inequality. Example 2. Solve d divided by 2 is greater than 7. So I'm going to rewrite it. D over 2 is greater than, that looks like greater than or equal to, is greater than 7. And when I'm doing inequalities and I write my 7s look a lot like greater than, so I'm going to start putting a line through my 7s. So that's why people do that, if you ever wondered why. Multiply both sides by 2 to get d by itself. 2 times d over 2 is just d, is greater than 7 times 2, which is 14. So d is greater than 14. Let's check our answer. And I'm going to erase this. The solution is d is greater than 14. You can check the solution by substituting a number greater than 14 into the inequality. Let's do the got it problems. A is 4x is less than 40. We have to solve for x. So we'll divide 4 on both sides of the inequality. 4x divided by 4 is just x, is less than 40 divided by 4, which is 10. So x is less than 10. For B, 6 is greater than or equal to x divided by 7. Multiply by 7 on both sides to get x by itself. 6 times 7 is 42. Is greater than or equal to x. And I always like to rewrite my inequalities so that the variable is on the left. So in order to make that true, I would write x is less than or equal to 42. Multiplication and division properties of inequality, negative number. So this is dealing with our negatives. What do we do when we're dividing or multiplying by a negative number? When you multiply or divide each side of an inequality by a negative number, the inequality symbol must be reversed for the inequality to remain true. For all numbers a, b, c, where c is less than 0, I could read this or you could look at it on your own today. So an example, 7 is greater than 1. If you multiply both sides by 2, or a negative 2, it becomes negative 14 is greater than negative 2, which is not true. So you have to reverse the symbol. So let me do an example down below. 5 is greater than 2. If I multiply both sides by negative 3, on the left it'll be negative 3 times 15, which is negative 15, is greater than 2 times negative 6, or times negative 3, which is negative 6. But I know that negative 6 is greater than negative 15, and so that's why I have to reverse my symbol. Example 3. Solve negative 2g is less than 10. Graph the solution on a solution set on a number line. So I'm going to use the division property of inequality and for negative numbers, and I'm going to divide both sides by negative 2. Negative 2g divided by negative 2 becomes just g. I have to switch the sign. So instead of being less than, it's greater than now. And 10 divided by negative 2 becomes negative 5. So g is greater than negative 5. Now let's graph this on a number line. So if I have negative 5 here, and I have negative 6, negative 4, negative 3, negative 7. Okay, I've got some numbers on the number line, and because it doesn't have the or equal sign to it, it's going to get a circle that's not filled in. So -5. And then since g is greater than -5, it's anything to the right of -5. -4 is greater than -5. -3 is greater than -5. And so that's how I shaded it in. Let's see if I'm right. Oops. Okay. So, yep, the book had exactly what I had for that problem. Number 4, solve x over -3 is less than or equal to 4. Oops. X over -3 is less than or equal to 4. If I multiply both sides by a negative, I have to switch my sign. -3 times x divided by -3 becomes just x. And 4 times -3 is -12. So x is greater than or equal to -12, and now I have to graph that. -12 here, and then I'll write -11, -10, -13, -14. And now this one gets filled in because it's greater than or equal to, and any number greater than 12 or -12 would be like -11 is greater than -12 and -10. So I'm going to go this direction. And that's my graph. So let's see if the book had the same thing I did. And they did. Let's try the got it problem. So for k over -2 is less than 9, multiply both sides by 9, or actually multiply both sides by -2 to get k by itself. This becomes just k. And since I'm multiplying by a negative, I have to switch my sign or reverse it. 9 times -2 is -18. So k is greater than -18, and then I can graph it on this number line. -18, -17, -16, -19, -20. And it doesn't get filled in, it's just a circle. And since it's greater than, I'm going to go this way. -17 and -16 are greater than -18. Okay, Ling earns $8 per hour working at the zoo. Write and solve an inequality that can be used to find how many hours she must work in a week to earn at least $120. Interpret the solution. So I wasn't really sure what at least meant, if I should use the less than or equal to or greater than or equal to. So at least I'm looking at my, I remembered that I had this chart from page 498 from our last lesson. So I substituted that in to this slide, and now I'm looking for the words at least. Okay, is at least. So it's going to be greater than or equal to. So $8 per week is greater than or equal to 120. So now I'm going to solve for W for the number of weeks by dividing both sides by 8 to get W by itself. 8W divided by 8 is just W, is greater than or equal to 120 divided by 8. So I know 120 divided by 4 is 30. So 120 divided by 8 has got to be 15. All right, let's see if I was right. Oh. Okay, so this is a little strange. Sorry about that. But I can make this bigger again. There. So it says write an inequality, divide each side by 8. I did that. It was greater than or equal to 15. Woo! I'm on fire. Okay, this was the notes video for Chapter 6, Lesson 7.